Last session we learned about your programmable array logic or combinational PLDs of PAL, PROM as well as your PLA. So how to implement their logical functions which are in SOP form using these combinational PLDs of an array of AND gates and array of OR gates. We discussed it. But now in today's session let we learn about so your digital systems not only designed using your combinational PLDs or your AND arrays and OR arrays, but also we have to use some of the sequential circuits which are your basic one flip-flops. So using that flip-flops also we have to implement your digital system. So digital systems mainly they are included with that logical gates along with flip-flops. So since that, so we have to design circuits along with the flip-flops with the logical gates. So now, so they are majorly we have sequential programmable logical devices which can design your sequential circuits. So now, so these sequential programmable logical devices which consists of one of the flip-flop along with the PLDs. So there are basically SPLDs are, so in the short form we call it as a SPLDs are classified into sequential programmable logical devices, complex programmable logical devices, as well as your field programmable gate arrays. So in these three categories, so we will have your a collection of your programmable AND array and programmable OR array along with the flip-flops. So basically in your sequential programmable logical device, so we are going to use your D flip-flops. So and these D flip-flops are edge triggered D flip-flops, so which are controlled by your clock signal. Now, so the AND OR array, so which is we can use either a programmable array logic of combinational PLD or programmable logic array. So the difference between PAL and PLA is so in both these PLDs AND gate is programmable, but in PAL the OR gate is fixed one, whereas in PLA the OR gate is programmable. So hence here almost we will prefer your PAL combinational PLD, and these inputs are transmitted through this array of your AND gates and OR gates. Outputs can be derived from its combinational circuits or combinational PLDs, or we can also obtain your outputs from the flip-flops. The flip-flops outputs are also fed back as an input which can give you the present state of the circuit. So now sequential circuit output will depend on your AND OR array, or you can also derive your outputs from the, or you can consider your outputs from its flip-flops. So based on your the design or the application, so you can directly take the output from the PAL, or you can take the output from your flip-flops. So this is the difference between your combinational PLDs as well as your sequential PLDs. So these sequential PLDs are implemented using your basic cell called as macro cell, and a SPLD or a sequential programmable logical device is a collection of 8 macro cells. So such type of 8 macro cells can form one of the sequential programmable logical device. So this macro cell can consist sum of product combinational logical functions with an optional D flip-flop. So here we have your AND and OR array as like in our PAL. So AND gates are programmable, where OR gate is a fixed one, and the OR gate output is connected as an input to the data flip-flop, where this data flip-flop clock is a edge triggered one. So you are using your positive edge triggered flip-flop. So for the raising edge of your clock signal, so it can change its state of the circuit, or it can change its output. Now, so we have taken that output of your flip-flop is through your buffer, and that also be taken as your one of the input. So since I have here only two inputs, now those two inputs, so let I label with the AB. So here the first line indicates your input 1, so I0. So let I take this is your I0, and the first line will be the I0, second line will be the I0 bar. So third line will be your I1, complement of your I1 bar is obtained from your fourth line. Next, present state not to obtain the present state. So we are taking that output of your D flip-flop, which is a complemented one. So Qn bar is transferred through this buffer state. So this fifth line will give you the present state of Qn. Sixth line will give you the complemented state of your present state as a present state of Qn bar. So along with this, so we have taken that output of your D flip-flop Qn with this buffer as it is connected to the output enable. Along with this input, so you also have your clock signal, where this clock signal can synchronize your operation of the D flip-flop or the state of the D flip-flop. So whenever raising it on your clock is applied on your clock signal, then only the state of the flip-flop will change or the output of your macro cell will change. So now, based on your requirement of your product term, you can program your these all the total we have here 5 number of AND gates here. So you can program your AND gates and you can obtain your the required product terms, and those product terms are odd using your OR gate. So OR gate output is connected as the input to the D flip-flop input. So like this, so we can also implement the sequential circuit by introducing here one of the data flip-flop, and with that, so we can also design the applications of your sequential circuit, like designing your serial adder or designing your sequence detector. So these all can be performed here. These all designs can be done with the use of your sequential programmable logical devices.